we're going to look at conditional probability. So a conditional probability of an event is a probability obtained with additional information that another event has already occurred. So the symbol here is P of B given A. So we're finding the probability of B given that A has already happened. And the little formula is the probability of A and B over the probability divided by the probability of A. I'm going to put or use method shown. So I'm going to show you how to do this a little more intuitively. So problem number 1 says, below you'll find some data regarding 85 flights for 2 airlines for a week in July. So we have Outback Airlines and Up Airlines, and if they're on time or late. So for Outback, 42 were on time, 3 were late. For Up Airlines, 35 were on time and 5 were late. So part A here says, what is the probability that a randomly chosen flight was late, given that it was an Upstate Airlines flight? So the given that it was an Upstate Airlines flight means we only want to look at the Up Airlines. So our total will be the total of Up Airlines, not of all of them. So that 35 plus 5 would be 40. Then we're going to find the ones that were late just in there. So that would be 5. So we'd have 5 over 40, which reduces to 1/8, or as a decimal is 0.125. Okay, I'm going to erase that so that we're prepared for our next one. So the next one says, what is the probability that a randomly chosen flight was an Outback Air flight, given that it was late? So since it's given that it's late, that's what's going to go in the denominator. So the denominator is going to be the total of whatever is after given. So with late here, we have 8. Then we're going to look back and it says Outback Air. So just in the late, we want Outback Air, which was 3 of them. So we'd have 3/8, which as a decimal is 0.375. Okay, so we're going to look at another example here. So it says, a survey of community college students revealed the following information regarding the gender and major of students. So we have whether the students were accounting, business administration, nursing, or engineering, and if they were male or female. So part A says, find the probability that a student is a male, given that the student is a nursing major. So we'd go to nursing. Only going to look at the nursing for this problem. So on the bottom, we're going to put the total number of nursing. So 11,227. And we wanted male, given that they're nursing. So we're going to put the male nursing students in the top. So 3, 6, 9, 7. And if you reduce that, you get 0.329. Part B says, find the probability that the student is female, given that the student is a business administration student. So since it's given that they're business administration, our total is going to be the total of business administration. So 10,925. I don't know why I wrote a 7 there. Okay, and we want the probability that they're female. So we're going to look at the females under business administration. So we'd have 5,795. So this gives us 0.269. And the last one here says, find the probability that the student is a business administration, BA major, given that the student is female. So here we want given that the student is female. So if we go back and look at that table, if we want female, given female, we're going to take the total number of females. So 21,571. And we want that they were a business administration major from there. So 5,795. And as a decimal, this gives us 0.269. So just remember, when you see the words given, whatever comes after the given, that total is going to be the number in your denominator.